Hello everyone. In this topic, I will be explaining about squeeze theorem. If a function is between two different functions, to find the limit of the middle function, we will find the limit of one of the functions on the right or on the left, because according to the squeeze theorem, limit on the right of the function is same as limit on the left is also same as the middle of the function in the middle. In order to find the limit of the function in the middle, we either find limit on the right or limit on the left. For example, in this exercise question, it says use squeeze theorem to find the limit as x approaches to 0 of f of x. This is the middle function. It's enough for us to find limit as x approaches to 0 of 4 plus x or 4 minus x squared. Use one of the limits. So I will show you both to show you that the limit is same on the right and on the left. So we are going to take limit as x approaches to 0 of each function. So on the left, 4 minus x squared. In the middle, it's f of x, and on the right, it is 4 plus x. So now let's find the limit on the left. On the left, when you substitute 0 for x, 4 minus 0 squared. In the middle, I still don't know. On the right, when you insert 0 for x, it's 4 plus 0. So 4 minus 0 squared is 0. 4 plus 0 is, excuse me, it's 4. 4 minus 0 is 4 on the left. 4 plus 0 is 4 on the right. I know the limit on the right. I also know the limit on the left. So I'm sure that limit on the limit on the middle is same as right and left. So this is also 4. Okay, answer to this question, it is 4. I just showed you right side limit is same as left side limit. That's why the middle limit is the same. So I solved both sides, but you don't need to do that. It's enough for you to find limit either on the right or on the left to save time. You don't need to do all. All right. Second question. It's also an exercises part in the book. I am looking for limit as x approaches to a of f of x. That's what I have in the middle. I have no idea about this, but I know that limit as x approaches to a of the right side, which is b plus absolute value x minus a, is same as limit as x approaches to a of left side, b minus absolute value x minus a. Find one of them. Let me try the left side. Insert a for x, so b minus absolute value a minus a. A minus a is 0, b minus 0, b. So left side limit is b. So since we are talking about squeeze theorem, I don't have to continue finding limit on the right. It's also going to be b. The middle limit will also going to be b. So our answer is b. Let's take a look at the ministry question. By using squeeze theorem, find the limit as x approaches to 1 of f of x. So, take limit of each side. Limit as x approaches to 1 of negative 2 is less than or equal to limit as x approaches to 1 of f of x, which is unknown, less than or equal to limit as x approaches to 1 of 2 cosine pi x. So pick the easy side. Which side is easy? This side looks easier to me. It's a constant number. When I insert 1, there is nothing to insert. There is no x to be replaced by. So it is itself negative 2. If left side limit is negative 2, Middle limit is also negative 2, right side is also negative 2, so that's what I am looking for, negative 2. You can solve this question by eyes without using your pencil. Okay, another ministry question which is smarter than this. Alright, we need to find limit in the middle. We need limit as x approaches to 0 of f of x by using limit as x approaches to 0 of right side or left side. Limit as x approaches to 0 of 7 minus sine 2x over x. So let's use one of the sides. Sine or tan, it doesn't matter. So let's use this side. So when I insert 0, what happens? 7 minus sine 0 over 0. I have an undetermined form here, 0 over 0 condition. So what do we do when we have 0 over 0 condition with trigonometric functions? Remember the rules. If there is sine something over x something, then it is coefficients of x's, right? So it's the coefficient of x at the top, it is 2. Coefficient of x at the bottom, it's 1. So it's 7 minus 2, which is 5. Left side limit is 5, so right side also must be 5. The middle side also must be 5. So that's what I am looking for. So answer to this question, it is 5. Alright, so this question involves sequence theorem plus undetermined form. So 2 topics in one question. It's a nice question. This was the first type. The limit of the middle function is asked when you can find limit on the right or limit on the left. We have another type of questions. Check it out question. Use sequence theorem to find the limit. Limit as x approaches to x, sine 1 over x. So we don't have such condition here. Here you see a function is placed in between two functions, but here we don't have such situation. The situation is different, but question still tells us to use squeeze theorem. So we have different methods here, like, okay, when you see this, you may remember oscillating behavior. Whenever you have limit as x approaches to 0 of sine 1 over x or cosine 1 over x, then you have oscillating behavior. Remember from the previous lesson, we have oscillating behavior when the angle of sine or cosine is undefined. When you insert 0, the angle will be undefined, so it's an oscillating behavior. When we have an oscillating behavior, limit does not exist. But here, we don't have just oscillating behavior condition, it's multiplied by something else. So it's x times sine 1 over x. So generally, we can say an oscillating behavior is multiplied by an x function, then it's not oscillating behavior anymore. So what is it? Let's see. We are going to use the range of sine or cosine function. So what's the range of sine x? Remember the range, have to find range. It was from negative of the coefficient to positive of the coefficient. So the coefficient of sine is 1. So we know that sine x is between negative 1 and 1. But what I need here in this question is not sine x, it is sine 1 over x. So I should change the angle here. What happens when I change the angle? Does it affect the range? Remember, it doesn't. Range is about outside, it's about the coefficient. It has nothing to do with the angle. So when I change the angle, I don't change the range. It's still between 1 and negative 1. And I'm not done because my function is not sine 1 over x. It's x times sine over x. Sine 1 over x. So I should multiply sine 1 over x by x. X times sine 1 over x. And To keep the balance, whatever I am doing on one side of equation or inequality, I should do the same on the other side. If I am multiplying the middle function by x, I also should multiply right side and left side by x. X times 1, x times negative 1. So on the left, I have negative x. On the right, I have positive x. In the middle, I have what's given. Now I have the previous condition. So this is exactly how it looks to the previous condition. Right? It's similar to the previous condition. The middle function is squeezed between two different functions. So the steps are same. To find the limit in the middle, you'll find the limit on the right or limit on the left. Or to make sure both. So now let's take limits of each side. Limit as x approaches to 0 of negative x is less than or equal to limit as x approaches to 0 of x sine 1 over x less than or equal to limit as x approaches to 0 of x. Now I need limit of the middle. So it's enough for me to find right or left side. What about the right side? Let's check the right side. What is limit as x approaches to 0 of x? All you have to do is insert 0 for x, which gives you 0. Or on the left also you do the same. Insert 0 for x, negative 0, which is 0. So if right side limit is 0, left side 0, middle side is also 0. So that's my answer. The answer is 0. And the good news is, whenever you have an x function multiplied by an oscillating behavior like cosine 1 over x or sine 1 over x, or sine or cosine 1 over x squared, 1 over absolute value x, so whenever your angle is undefined, that's called oscillating, remember. So oscillating multiplied by an x function gives you 0. So this goes for every type of this condition, like x times cosine 1 over x, it's 0. Absolute value x, or having x squared, x cubed in front, so you have an x function multiplied by sine or cosine of 1 over something, 1 over x something, x squared, x cubed, absolute value x. All of these examples, the result will be 0. All right. So we have one ministry question about this came so far. They all have the it also has the same idea. It's one of them. All right. So we are done for squeeze theorem.